So in this question, we've been asked to find the gain, V out in terms of V in. In this case, V out is fixed to be 10 volts. So we're asked to find what V in is fixed at 10 volts. So we're asked to find what V out would be given the different Rx values. We could create an equation that in terms of Rx, and then plug in 0, and then plug in R1, and then plug in infinity to see what we get out. But it's easier if we just plug in straight up, because there's only 3 of them. R equals 0, Rx equals 0, equals 1, equals R1, and equals infinity. So let's start with the first one. If Rx is 0. If Rx is 0, that means it's going to be a closed circuit. It's straight to ground. Which makes things very simple. Because then this node would automatically be 0 volts. If this node is 0 volts, that means this node is also 0 volts. And if that's 0 volts, then we can easily calculate the gain of V1. Simply as we do the negative feedbacks, you just use Ohm's law, plus minus, I1 must equal to I2 because no current going in. Well, then we can just say this would be V1 minus 0. And this is V out over here with respect to ground. So simply then it would equal to negative R1 over R1. This is the gain, so we'd say V out is equal to V in. If you're a little confused, you can go back to the negative feedback that I had. Current coming in is going to go out through here and out. Because since this is grounded, that means this is automatically 0. Which means this node is automatically 0. Which means that's how we can create an equation for the gain. But what if it was R1? If this was R1, then this voltage would not be 0. And how would we calculate it? We can use voltage division. If this is R1 and R1, that means half of the voltage would be dropped across this resistor, and the next half will be dropped across this resistor to go from V1 to 0. In other words, then this voltage would be equal to V input over 2. That's what it would be, because this would drop half of it, half of V input, and this second resistor would drop half of the input resistance, and you'd be at ground. If that's the case, that means this would be V1 over 2. So I would just do the same thing I did here, but it'll be a lot more difficult. So to create the equation, V1 minus V1 over 2 over R1, that's the I1, must be equal to I2, and what is I2? In this case, VI over 2 again, minus V out over R1. Bring the R1 to the side. The R's can cancel out. I have a V input here. Minus a half of V input is 0.5 V input. Minus a half of V input, which would be equal to minus another half of V input. And so what happens? They cancel out. Which means V out is equal to 0 volts. If I make them equal, there will not be any output voltage. So as you can see here, V out is equal to 0 volts. Straight up. What if it was infinity? Infinity would mean this whole thing didn't even exist. Then, to calculate that, you'd see what voltage drop does this resistance cause. But remember, if current went through here, well then where's it going to go? It cannot go into an op amp. So no current is going to drop on this resistance, which means then this voltage is the same as this voltage, which is V1. But then that must mean this must be V1 as well. If this is V1, then I would have Ohm's law, V1 minus V1 over R1. Well, V1 minus V1 is 0 over R1. which is 0, which means no current is even going through here. And if no current is going through here and no current can come in, then no current is going to come out or in through this feedback. So, in simplest terms, I'm just show the equation quickly. V1 minus V1 over R1 must be equal to, this node is V1 as we said, because there's no current. V1 minus V out over R1. R1's cancel. V1 minus V1 is 0. Negative V1 comes to the other side. You cancel out the negative. And as you can see, V out is equal to V input. The voltage would be exactly the same. So then we can say from this, if Rx was infinity, V out would be equal to V in.